Welcome to ICP7 presentation. I'm going to present the K-means algorithm for clustering. So in the class, we have learned how to do coding for the clustering, especially the K-means algorithm. In this particular presentation, I'm going to do some work done by me using a different data and also to analyze the data, show the results for different number of clusters. Speaking of the data, I have used the mall customer segmentation analysis data from the Kaggle. I have shown the link to the Kaggle here, and I have I put the data in the document as well. I mean the link in the document as well. Also, I put the data in my GitHub repository. So um, we as a first approach, I have uploaded the data to my Google Drive, and uh, from the Google Drive, I loaded the data and did the analysis. But before going to the technical details, let's see what is the context here. So the goal we want to accomplish here uh, is to cl classify the data, classify the customers in a way so that we can minimize the interclass similarity and maximize the intra-class similarity. So uh, these two criteria basically mark the quality of the clustering process. Now, these are the libraries that we are using. So we imported the libraries first, then mounted the Google Drive and basically read the data. So there are 5 columns in the data: customer ID, gender, age, annual income, spending score. So our problem statement is, can we classify the customers according to their age, annual income, and spending score so that we can establish a pattern and we can make a business case out of that. So um, first, a tiny bit of cleanup. We drop the customer ID from the data. We don't need it. That's why I dropped it. Now let's do some data quality checkups. First, we plot the frequency distribution of the age. And the frequency distribution shows the clear distribution of the age. I mean, the central tendency is kind of the centroid, I can say, is kind of here. So it's slightly more than 30 years. Then the annual income frequency is about, I mean, 60,000, central tendency again. The spending score is about, let's say, 50. And then number of customers plot, you can see that there is clearly more female customers than the male customers. So if our problem would be one dimensional, then it's very easy. I mean, we can look at these plots and we can classify the customers. But our problem in real life is not one dimensional. So we need multiple variates. So let's do some analysis based on age, income, and spending score. We have also created age distribution for the customers and one dimensional, and we can see 26 to 35 age group is prevalent. Same distribution is shown for spending scores and annual incomes. We can see the clear classification. So once we go to the uh, trivariate distribution, that is age versus um, spending score versus annual income, then things get complicated, and then we apply the k-means algorithm. So we define the k-means function with initialization as k-means plus plus, and they feed the k-means algorithm on the data. And of course, we can derive some inertia here. So let's try to do some uh, inertia analysis for different number of clusters. So the variable that we are interested in is a derived variable, and that is called WCSS, which is basically within cluster sum of squares. The within cluster sum of squares is a measure of the variability of the observation within each cluster. A cluster that has a small WCSS is more compact than a cluster that has a large sum of squares. So we plot WCSS as a function of number of clusters. So we can see that this curve is like an elbow, and this is a famous elbow plot, in fact. And the indicator is the point from where the uh, inertia starts diminishing. Is that point is called the optimal number of clusters. That means that many number of classes we can form in the customer based on our variables. Those are there are three variables in this case. Those are basically age, income, and the spending score. So now let's uh, plot the figures for five different cluster sizes. I mean, five different number of clusters: 5, 6, 7, 8, and 9. So let's see what are the results. This is the five cluster scenario. We can see kind of clear uh, regions of five clusters. If we increase the number of clusters, the overlaps increases. The similarity between different clusters increases, which we do not want. Even if we make the number of clusters to be 7, more similarity across the clusters. Number of clusters 8, even more similarities. It's kind of trying to become a single patch. Um, K equals 9 is it's not a good scenario as well. So we can conclude that five clusters scenario represents the number of classes for the customers uh, the within the variables of our problem. So from this exercise, I have clearly learned how to do k-means analysis using Python and other k-means libraries. And then I have used a separate independent good data set to establish the clustering of the customers according to their age, income, and spending scores. So that's all from me right now. Thank you.